It's actually the first time I'm at the IPDB Meetup, so it's nice to be here, this group. So there are a lot of things I could talk about, but I decided to talk about Ethereum governance mechanism. As you know, the DAO was also more or less about governance, some sort of, and it also showed a lot of, when the hard fork happened afterwards, what is the Ethereum governance? And what is the definition of it? What can be approved? What's the current state? When we speak about blockchain, my favorite definition of a blockchain is actually a distributed permission ledger. It just manages who has which rights. And therefore governance is a very important topic, because actually what you do when you write a smart contract, you just program who's allowed to do what. And that's a very fundamental feature of the blockchain. But we have not really used it yet for actually governing the protocol itself. And that's what I will get into. So the first question is, what to govern? So you would have the protocol. I'm speaking here mainly about Ethereum, but you can also apply this to other blockchains. There you have something, you need emergency fixes, as we saw with the last two hot forks, which were mostly a fix on the protocol because there were DOS attacks. And those DOS attacks happened because of a not optimal price strategy of the opcodes in the Ethereum virtual machine, and it needs to be fixed. And then we have protocol upgrades. For Ethereum, this will mean proof of stake, sharding, the new Ethereum virtual machine. We're thinking about using WebAssembly actually, or opcode gas pricing and different things. So we know in Ethereum you want to upgrade the protocol a lot. And currently this just means you have a hard fork. And then the question is, who's managing this, who's writing this, who's specifying it? Those are questions. Then you of course have those decentralized application or dApps. And there you have also different kind of dApps. You have infrastructure dApps. For example, the Ethereum name service, which just defines you can give it an address and a string, a name so to say, pointing to it. And this is a very critical dApp which runs as a smart contract on Ethereum. It will be used, for example, also by Swarm. Swarm is, I hope most of you know about Swarm. It's also a bit similar to IPFS and IPDB, but it's not directly the same, but going into the same direction about having decentralized content. You address the storage by content hashing, so it's a very similar principle. And those smart contracts are also dApps. And that's also a question, who governs them, when they want to be fixed or updated, who's doing this? Then you have regular dApps, and they usually, I would say, they can build in the governance themselves. The DAO, for example, had a governance. The problem was there just that it has a time of 2 weeks for the DAO token holders to decide anything. So the governance was not good enough to do emergency fixes. They have only seconds or days. This was, there usually dApps are not good at. You can also have a central authority in your dApp controlling everything. You can have multi-sigs controlling something or some sort of consortiums. You can have token holders if you have some, deciding something. Or you can even have decentralized escape hatch. I wrote a smart contract where just let Ether holders allow them to shut down your app basically. This can also be done just in a smart contract. So meaning that apps can decide for themselves who governs them, and they can do this themselves. So I don't want to talk about governance for dApps, but maybe for infrastructure dApp, but I will speak more about governance on the protocol level. So the first question we have to ask in a blockchain, especially Ethereum, which parties are actually involved in the whole ecosystem? And it turns out it's quite a lot. So this is a list, and I think it's not complete. But the main point is, can we verify them on-chain? So can we actually have on-chain or on-protocol governance, including those groups? If you go through them, first we have the miners. Those are the easiest one. Yes, you can in smart contract, block.coinbase, this is Solidity code here. You can address them. So you can give miners powers to decide things. That's completely feasible to do in the protocol. Then of course, also very easy, those owning Ether or token holders, stakers, there's no problem. An interesting one are users. How would you define users? Users are not necessarily defined by how much Ether they have, but by how much they use the blockchain. If you want to give them some control. Actually, it turns out it's possible too. You can just measure how much transaction fees they are paying. And so you can give them voting rights depending on how much transaction fees they are paying to use the system. So they are possible to have on-chain governance. Then you would have speculators or traders I would say, daily price discovery, which is not necessarily on the blockchain, which usually happens on exchanges. There you could think about, you could have smart contracts where you have prediction markets or something like this, where you could have them in there sort of, but not directly at least. You have client developers. They can be identifiable through a special key pair. So you could think about a Go client, a parity client, and you have all those different Ethereum clients, and they could have a key, so they have something to say. It's possible at least. Then another interesting one is, we are always focusing on developers, especially dApp developers. Can we measure somehow dApp developers on-chain? It's difficult, but one idea would be, you can think of the message sender of a contract creation, so who created a contract, and then you can give a contract a certain value by saying how much is the contract used in terms of transaction fees. So how much transaction fees were paid to use this contract, or for example, how much Ether is it holding. And you can think about a nice formula to give dApp developers some power, saying yes, you can measure how much impact those dApp developers had on the Ethereum blockchain, how much value they created. Of course, you have the foundation. They have a foundation multisig which can be used. And there are other groups, researchers, regulators, and so on. That's a bit more difficult to give them direct governance. But it already turns out there's a pretty large group of miners, stakers, users, client developers, even dApp developers and foundation, which can be identified on-chain, where we are actually able to have some sort of governance. Okay. So now let's look at what do we have today. What is the Ethereum governance model? Do we have actually anything defined? For dApps, it's clearly do-it-yourself, no question. On the protocol level, there is actually one thing that we do have on-chain governance. And this is only one parameter, which is the block gas limit. It is similar to the block size in Bitcoin world. In the Ethereum world, we have a block gas limit defining how much computation can be done in one block. And the current rule is that each miner can increase or decrease this value just a little bit when he mines a block. And this turned out to be very effective during the last attacks. We call them the Shanghai attacks during DEFCON 2. Ethereum was attacked very hard, and it turned out this was very effective for emergency phase. Basically, the foundation and some thought leaders, they called on the miners, please reduce the block gas limit down from, it was about how million, 4.2 something million, down to 1 million. And they did so almost immediately, which did help a lot, because then the block gas limit was so low that the attacker couldn't do that much damage. So it was very helpful, it was very fast, and this was the only parameter where we do have on-chain governance currently, where only the miners decide what to do. And I forgot one. There's one other thing. It's called, I call it a difficulty bomb. Right now, this was built in when the frontier started, so almost 1.5 years ago. We built something in the protocol that the difficulty to create a block would increase exponentially. So about, I think it's only 4 or 5 months we have, so this summer, the Ethereum blockchain will become unusable unless we do a hard fork. So actually there's this rule, the difficulty bomb, forces every user of the blockchain to update. So if no hard fork would happen until I think October, September, something around this, then the block time would increase until exponentially, and nobody would be able to mine another block. So here we force people, this was actually put in because when we want to move to proof of stake, the miners, so game theoretically the miners have no incentive to accept the change from proof of work to proof of stake. So therefore the difficulty bomb was put in place, so they can't do anything, they have to update. This is some sort of governance, a very harsh one, but those are the current on-chain governance model. If you look at off-chain governance, it's very undefined, but you do have the Ethereum Improvement Protocol, EIPs, Bitcoin we have something similar, and there you would have some thought leaders, foundation or client developers. They can suggest changes to the protocol, and only they, the client developers, can actually implement them and offer them to the public. And only if the client developers say, yes, we do implement this EIP, then to a hard fork usually, then users can say, yes, I accept this, I want to go with this. This is currently how I would say Ethereum governance is working today. I have to say that the foundation and the client developers are doing a very good job. They are listening to the community, they are asking, it's a very open discussion. So I'm not saying here that right now this is bad and that we have a dictator, which is Vitalik, which is not really the case. It's a very open, good discussion. I'm very in support of what they are doing. But this is how it is today, and it's not very well defined, I would say. It's somehow, but it also has a positive thing, because if you leave something open, you have a more social consensus, makes it very hard to do a hard fork, which is also good. There should be some social price to be paid if you want to convince the majority to update the protocol. So that's how I would describe the governance model of Ethereum today. Yeah. So the question is, can we do better? And there are several suggestions out there from different people about how Ethereum governance can be improved. But those are the challenges, and I would not say they are really solved yet. One very important one is protect minority rights. Because if you go for the very simple solution and say, oh, you just let Ether holders vote on everything, then you could say, game theoretically, it makes sense for them to vote on, just say 49% of the people lose all their Ether and give it to 51%. And usually they would say, yes, that's good. And you don't protect any minority rights. Then the question is, can we avoid hard forks for simple protocol updates? For example, the hard fork we just had recently, they just changed gas price of opcodes. Those are just constants in the protocol. They can easily be managed by a smart contract. So can we do this in a smart contract so we don't need a hard fork for every little update? Can we offer a bit more certainty on governance, especially from enterprise users? The request comes, who's governing this Ethereum thing? Oh, it's a community. So that's nice to hear from them, but it's not really reliable. And especially faster decision processes in terms of crisis or emergency, DOS attacks or something like this. Can we include all the relevant parties in those governance models? So those are the challenges, and they are very hard and they are not really solved. But I will just give you an overview of what has been suggested so far. So the most sophisticated one is actually from Dominic Williams, called the blockchain nervous system. And he's implementing this on his own project called Definity, which is, he calls the crazy sister of Ethereum. So it's a different blockchain, its own. And there is something which is, the blockchain nervous system is like an omnipotent, he calls it an AI, because everything is AI nowadays, which is software, which is controlling everything on the blockchain, which can shut down apps, change protocol parameters, can do basically everything. And this blockchain nervous system works like this, that if you have some definities, you can put it as a deposit, then you get some, how does he call them? It has a nice names for them. From the nervous system, the end of it. I don't remember the name right now, but you get basically voting power if you deposit some of your definities. And it takes, for taking them back, it takes 3 months. So you have to make good decisions, good governance decisions with your voting power, that the value of the definities increases. So that's his system. He allows for anonymous voting. He allows for delegates, that you can say, I will give my voting power for project questions to this guy. I give my voting power when it comes to shutting down apps to this guy. So you can basically give voting power to delegates if you want to. But this is a strongly governed blockchain where you don't have anything which you could call code's law or something like this. It's completely governed by the token holders. That's one model. Another thing is the Yellow Paper Committee. Gavin Wood, one of the founders of Ethereum, the author of the Parity Client or ETHCore, he suggested to have a committee. This is more like a DAO. You could think about it as a multisig. And all they do is provide a hash of the current yellow paper. The yellow paper is a technical specification of the Ethereum protocol. You could think of it, they make changes to yellow paper, they hash it, and this one multisig decides what is the current hash of the yellow paper, and thereby define the protocol. And they would have rotating roles in there, and yeah, you can go, I have a link here, maybe those, I can distribute the slides so you can have a look at the details, but basically having a consortium deciding this is the current protocol. Then we have something which was just a suggestion for discussion only from Vitalik, called the Bomb 2.0. To give you a short explanation of what this is just when hard forks happen, to basically make the old chain valueless, worthless. So how you would do this, you would have a smart contract which is full of ether, and the majority of ether holder can trigger the bomb, say in 2 weeks everybody can get as much ether as you want from this contract. So now we do a hard fork, and the old guys, in order to deactivate it, they need a maturity, which they don't have. So in the case, for example, for the DAO hard fork, if something like this would have been in place, then the maturity, if they would have voted for the DAO hard fork, meaning the old chain would be worthless because you would have had hyperinflation there. This is just an example of if you do hard forks to remain united on one chain. It's hard. It's open to discussion. We have not implemented it, but it could be one way to at least do hard forks without having several chains after this. Of course, they are always free to do hard fork again, but at least people need to make an active decision.
Can we ask questions now or later?
This is the last slide. So I think it's the last. It's 2 slides. Then we are done. Then you can discuss this. So one is actually this is one EIP which I did propose, which is actually fairly simple. My proposal is to put every constant in the protocol. Right now, this is mainly the prices of opcodes into a smart contract, and then let miners and/or stakers govern on deciding what those numbers are. So you could think of the last hard fork where we just changed the price of some opcodes like balance and call and others. Those constant numbers, so magic numbers in the protocol, can all be a smart contract. And I think miners are good to govern those numbers because they have an incentive that those numbers are right, that they have optimal mining strategy, and they have low transaction fees for transactions. So this at least is not a complete governance of everything, it's just some important protocol parameters. So as a conclusion, the first question is, do we really need better on-chain governance? Or actually is it good to don't have anything like this? Similar to Bitcoin saying, yes, it's just free and there's nobody having any governance. But if we say, yes, we want to have better on-chain governance, then I think we do have a bit of a chicken-egg problem here. The question is our current governance model good enough to decide on a different one? And right now, I would actually maybe say no, but I would be happily surprised if it's different. If you can make a decision on a more defined on-chain governance, I would really like this, but I don't see it coming right now, but it's a thing when the community pushes for it or discusses it a lot. It will be discussed more also in, for client developers. Okay, this was it. So I think now we can open this to questions.
Let's hold the questions till the end. We'll do the presentation.
Hi everyone, thank you for coming out. We're going to talk a little bit about a different governance system today. It's kind of quite a contrast to the Ethereum model. So it'll be interesting to have discussion after. I'm actually really looking forward to digging into some of these issues. So we hear a lot about governance now. It seems like every white paper now has at least a paragraph on governance thrown in to say we'll have some. But why? Why do we need this? What does governance do for us and why is it important? So the first is to provide a measure of accountability. That's accountability to participants, so designing systems that allow input on what's actually happening within the organization or within the network. And in blockchain models, that's usually based on some sort of economic model or game theory model. But we also want accountability to the public, so whether they're taking part in the system or not. And that's something that is kind of missing in most governance models, and it's something that we'd kind of like to address as well. So the other piece is responsiveness, responding to various situations that arise. So responding to emergencies, so we've seen that happen with the DAO and the quick response with the hard fork. Responding to changing circumstances as well, so making sure that things still work in a new world as unexpected stuff comes up. Bitcoin is really struggling with that right now. There have been a lot of developments in the Bitcoin ecosystem that really weren't accounted for at the very beginning. And that sort of inability to readjust the incentives between users and miners and developers is really causing some struggle there. So when I say blockchain governance, I mean sort of technocratic systems of governance that are largely done on-chain. So we talked a little bit already about the difference between on-chain and off-chain governance. So examples would be the DAO or the Ethereum network or Bitcoin. And there's a lot of talk in that world about wanting code to be law, to get rid of the lawyers, to replace the vagueness with really hard, clean code and predictability. And then there's also traditional governance. So with traditional governance, I mean things like corporate law, administrative law, systems like corporations or voluntary associations or charities. So traditional actually does have some benefits. So I'll put them in technical terms here. The first is that it's out of beta. Traditional governance has been running in production for hundreds of years now. It's given a lot of time to cut out some of the bugs. It's a little bit slower, it's a legacy system, but it's still extremely resilient. It's fault tolerant. It's not always perfect, but there are a lot of mechanisms built in that help you find errors, get around them, and deal with them when they come up. And it does it pretty gracefully. And it's interoperable. So traditional governance models are interoperable with every legal system in the world. They allow you to interface with all kinds of different organizations through a protocol called contract law, which has also been out of beta, and it's been used in production for about 2,500 years. So IPDB, for those who don't know, is a public, scalable, decentralized database with blockchain characteristics. It's built on it's a public instance of BigChainDB. And it runs on a federated consensus model. So we pre-select the validating nodes. And so we've decided to run IPDB on the traditional governance platform. So the first advantage of this is that it gave us a legal personality. So once the organization is actually established, we will have legal personhood, and the organization will be able to enter into contracts with any other legal person. And that's a huge advantage over a system like, for example, the DAO, which has some issues about that. Who are you contracting with if you go into business with the DAO? These are questions that aren't answered, and hopefully they will be. We've seen developments from the EU to kind of bring in these new models and establish legal personhood in those models, but it's not quite there yet. Limited liability. Since it's a legal entity, the members, the caretakers in IPDB, and the board members will not be responsible for the actions of the organization. It kind of provides a shield and provides legal certainty for people who want to take part. But along with that comes accountability. So as a charitable organization, IPDB's mission statement will be baked into its articles. It'll be legally binding. It'll be supervised by the German tax court. And it'll have annual member meetings to make sure that things are being done as planned. And this one keeps coming up in my presentations. I'm not sure why. It's there. There she is. Lovely So, this default slide on Keynote are wonderful. So, IPDB isn't immutable, but really what is? The articles in IPDB, though, are pretty hard to change. So, it requires a 2/3 majority to change the articles, or a 3/4 majority to dissolve the organization. And that defines things like the mission statement, how the board is selected, hard and fast rules about who gets to be a caretaker. For example, we've talked about this before, but we require that greater than 50% of the caretaker members be not-for-profit organizations. So under that framework for the articles, this is kind of the structure that emerges from it. We have a number of caretakers who are also the members of the organization. The caretakers elect a board that has more responsibility and kind of handles the day-to-day operations, and they're free to hire a staff to kind of take on even more of the day-to-day responsibilities. When new people want to become caretakers, the caretakers can comment on those new caretakers. There's a review period, and then the board will decide whether they meet the criteria or not. And the caretakers, of course, also operate the nodes in the network. So for caretakers, they're chosen for a commitment to the decentralized internet. We won't go through the whole list of them again, but we have some wonderful organizations lined up, and if you're curious, you can go to ipdfoundation.org/caretakers. We have the board that's elected by the caretakers, and we'll be announcing board members soon as the organization actually takes shape. The staff will be hired by the board, as we said. Advisors will be appointed by the board as well to help fill in gaps in expertise. So now we get into the really interesting part that we're working on right now, the bylaws. The bylaws exist under the articles. They're kind of the day-to-day operating manual for the organization. They are still hard and fast rules, but they're easier to change than the articles. So things like the process for selecting caretakers, finer rules about who can be a caretaker, so a wish list for things that we want, like maybe 2/3 should be not-for-profit organizations, or fewer than 25% from any given country, or fewer than 40% from any one region. Processes for actually setting policy around security, like how are keys generated and stored, what privacy rights do caretakers have, what obligations do they have to protect user privacy. Things like that can be easily managed within the system. It's quite flexible. But then there's also this really sophisticated review process built in, where if the caretakers aren't happy with how things are going, they're able to say, wait a minute, board, we don't like you anymore. And if 10% of them get together and agree with that, they can call a meeting, recall the board, and establish a new board, and hopefully put the organization back on track. So that's where we are with IPDB governance. It's quite a bit more flexible, but also it has the pros and the cons of being more flexible, and I think that's something we can get into in a bit more detail in the conversation.